Alright, this is the solution for problem 3 from quiz 5. So here we've been given what from class you might recognize as a Volterra integral equation. So we're asked to find a function x of t, which is given by an integral equation, right? So this looks like a differential equation, except it's got an integral instead, so we can call it an integral equation. So x of t here satisfies that it's equal to 4 times e to the t, plus 3 times, oh my goodness, what a complicated looking expression. Except if we think about the convolution, but we read the definition backwards, we might recognize this actually as a convolution. Okay, that's not too shabby. So let's try to write that down. So we have x of t is equal to 4e to the t plus 3 times. All right, well, what are the functions? So first, we notice the tau goes from 0 to t. Right? That's right, part of our convolution definition. Now we have an exponential, fine. So it'll be an exponential, and you notice here, this t minus tau, right? Remember, that replaced a t in our definition. So we must have negative t. Okay, and then we multiply by x of tau. Okay, this tau replaced a t, so we must have been convolving with x of t. All right, so this is another way to write this integral equation. We're hiding the integral by using this convolution symbol. However, by hiding it in this way, it's actually going to help us in our next step, because in this class, the way we want to solve differential equations, or in this case integral equations, is by using the Laplace transform. So let's take the Laplace transform of both sides. So L of x is going to equal 4 times the Laplace transform of e to the t. Let me just leave it like this for now. Plus 3 times the Laplace transform of the convolution of e to the negative t with x of t. Okay, so by the convolution theorem, I can break this Laplace transform of the convolution up into 2 different Laplace transforms. So this will be 4 times the Laplace transform of e to the t plus 3 times the Laplace transform of e to the negative t times the Laplace transform of x. All right, and I'll drop the of t, right? Okay, now as is usual when we're trying to solve a differential, or in this case integral equation, and we've taken the Laplace transform, right? We're trying to solve for the Laplace of the function we're looking for. So let's do that. Let's put all the Laplace of x's on one side. And let's see, on the left-hand side I had 1. And then I'm going to subtract over 3 copies of the Laplace of e to the negative t. And I'm just going to be left with 4 copies of the Laplace of e to the t. Okay, I can now divide and solve now for L of x. So L of x will be 4 times the Laplace of e to the t over 1 minus 3 times the Laplace of e to the negative t. Okay, and in class we did a more general version of solving the Volterra integral equation, and this is what it looked like. Now, we actually know from our table what the Laplace transform of e to the t and e to the negative t are, so we can go a little bit further here. Let's see, so Laplace of e to the t is going to be 1 over s minus 1. So put a 4 on top, and then we're going to divide by 1 minus 3 over s plus 1. Right? Again, the Laplace of e to the negative t will be 1 over s plus 1. All right, let's do a little bit of algebra. On the bottom here, we're going to get s minus 2 over s plus 1. Okay, just find a common denominator, s plus 1 over s plus 1, and then subtract. All right, so this means we get 4 over s minus 1 times s plus 1 over s minus 2. Okay, I want to break this up into a couple of different pieces, which I can then recognize from the table. So here's what I'm going to do. I'm going to split this up as 4 over s minus 2 times s plus 1 over s minus 1. All right. So I know that this first piece, that is 4 times the Laplace transform of e to the 2t. Times, okay, now I need this bit. Well, let's do a little bit of algebra on this guy. So this guy, I could break it up, and here's how I want to break it up. I want to write this as s minus 1 plus 2 over s minus 1. Whoa, where'd that come from? Well, I'm trying to get this s minus 1 to appear on top. I have an s, so I could insert. I just cheat. I'll insert a minus 1. But of course, I'm not supposed to have s minus 1 on top. I'm supposed to have s plus 1. So I have to add 2 more to get back to s plus 1. And the advantage of writing it this way is now I can split it into 2 pieces. S minus 1 over s minus 1, which would be 1, plus 2 over s minus 1. Now, I can break this now up as, let's write this in blue, 1 plus 2 over s minus 1. Well, actually, you know what? Let's just say what this is, right? 2 over s minus 1 is twice the Laplace transform of e to the t. Okay, so let's distribute a little bit. First I have 4 le to the 2t times 1 plus 4 le to the 2t times, oh, there's a 2. I can make this an 8 now. 2 le to the t. All right, well, this is getting pretty long, so let's go back and see what we had. We had solved for L of x. Our goal, of course, is to get to x, right? But we have solved for L of x. So L of x is equal to 4 copies of e to the Laplace transform of e to the 2t plus 8 copies of, well, before I copy this, I have a product of Laplace transforms. And, well, hot diggity, right? We have the convolution theorem, right? So I'll use the convolution theorem here to put these back together, right? We had used the convolution theorem up above to break things apart. Now we're going to put them back together. So I have 8 times the Laplace transform of e to the 2t convolved with e to the t. Okay, I can now apply the inverse Laplace transform to solve for x, and that was the goal. So in the first case, this is really easy. I get 4 times e to the 2t. And in the second case, I'm going to get 8 times the convolution of e to the 2t with e to the t. Now, in problem 2 from this quiz, right, go check out that video, we actually worked out a nice formula for this convolution, right? Only we had a, t, and bt. So let's recall what that result was. We had e to the at convolved with e to the bt, where a was not equal to b. We got that was equal to 1 over b minus a times e to the bt minus e to the at. Okay, let's see, is that what we had? We'll go up to the previous way. Look at that. You can see where we had done it. Beautiful. Okay, so we can now finally simplify this. 4e to the 2t plus 8 over b minus a. So what's my b here? Well, the b, I could think of this as a 1. That's my b. And the 2, that's my a. So b minus a is 1 minus 2. So that's negative 1. And then we'll have e to the, okay, again, our b is 1. So t minus e to the, okay, a is 2, e to the 2t. Okay, let's see what we get here. So we have 4e to the 2t's here. Then we're going to have minus 8, and then, oh, another minus, so that'll be a plus, another, right, 8e to the 2t. So in total we have 12e to the 2t's. Then we'll have minus 8e to the t's. And there we go. We have solved for x.